Okay, so when you think about AI, what's the first thing that pops into your head? It's probably lines of code, right? Or maybe one of those amazing images that just appears out of nowhere from a simple text prompt. But today, we're going to peel back that digital layer entirely. We're going to look at AI not just as software, but as one of the biggest industrial revolutions in history, one that's literally being built on a foundation of concrete steel and just unbelievable amounts of power. We see the magic of AI everywhere we look now. The instant answers, the wild creative tools, the promise of cars that drive themselves. But what's really powering it all? What's the machine behind the magic? In this explainer, we're shifting our focus from the shiny digital stuff AI creates to the colossal physical empire it actually needs just to exist. And believe me, that physical footprint is about to get way, way bigger, all thanks to the rise of something called agentic AI. We're moving so far beyond simple chatbots here. We're talking about autonomous systems that can handle complex, multi-step jobs all by themselves. I mean, imagine an AI that doesn't just tell you about a supply chain issue, but actually goes in and reroutes shipments to fix it in real time. This kind of leap in what AI can do requires an equally massive leap in the physical stuff that supports it. So let's start with the common idea. For most of us, AI kind of lives in the cloud. It feels weightless, almost magical, like it's everywhere and nowhere all at once. But as we're about to see, that is an incredibly powerful illusion. This one quote just shatters that entire illusion. AI is not a business of bits and bytes. Not really. It is, fundamentally, a business of atoms. And that forces a complete shift in how we think about it. The success, the growth, the very ability for modern AI to function is completely chained to a massive, tangible, and seriously power-hungry physical world. So let's pull back the curtain on this new reality. We're going to look at the actual physical parts and the real-world limits of AI, the stuff that's so often ignored but is quickly becoming the biggest bottleneck in this entire revolution. This list right here shows you the real-world hurdles. AI's growth isn't being held back by code anymore, it's being held back by physics and logistics. We're talking about needing gigawatt-scale power grids, which can take a decade and billions of dollars to build. We're talking about finding huge amounts of water just to cool down these data centers that run incredibly hot. You've got complex government permits, specialized construction crews, and the need to literally dig trenches to lay down webs of fiber optics. The future of AI is being built with concrete and steel, not just silicon. So how is this insane build-out even being paid for? Well, it's through this really unique financial engine. First, you have the giant cloud companies, the hyperscalers, like Microsoft and Amazon, and they pour billions into hot new AI startups. Then, here's the kicker. Those startups immediately turn around and use that exact same money to buy massive computing services from their investors. It's this powerful feedback loop where the money goes out the front door and comes right back in as revenue, which makes everybody look great and attracts even more investment. It's like pouring rocket fuel on this infrastructure fire. So, what does the physical body of AI actually look like? It's definitely complex, but we can break it down into a pretty simple three-part system. And if you can get your head around these three tiers, you'll really understand how the whole thing works together. This slide lays out the whole anatomy. First up, you've got the cloud. Think of this as the university where the AI goes to learn. It's where these huge models are trained on unimaginable amounts of data. This takes thousands of powerful GPU chips working all at once. Next, you've got on-premises data centers. This is where the AI actually does its job, a process called inference. It's like the AI using what it learned to answer your question. This is often done with custom-designed chips to keep costs down. And finally, there's the edge. These are the devices out in the real world, your phone, a self-driving car, a factory robot that need to make decisions instantly with basically zero delay. Each tier has its own super important job. Okay, now let's jump ahead to a really pivotal year, 2026. This is the year where all the forecasts are pointing to a critical moment, where the insane demand for all this physical infrastructure, especially electricity, is set to hit a breaking point. The numbers behind this are just staggering. Let's just follow the money for a second to get a sense of the scale. By 2026, global IT spending is projected to hit an incredible $6.15 trillion. And a huge piece of that pie, over $650 billion, is forecast to go directly into building and outfitting data center systems alone. But what's really driving this unprecedented spending spree? The answer's pretty clear. Worldwide spending on AI specifically is expected to skyrocket to over $2.5 trillion. AI is fast becoming the single biggest driver of the entire global tech economy.
But all this money, all these data centers, they all run into one very hard, very real physical limit. And this is the number that should really make you sit up and pay attention. By 2030, the power demand from AI data centers is projected to hit 156 gigawatts. To put that in perspective, that's more than the entire energy consumption of many countries. This is putting a massive, unprecedented strain on power grids around the world. And it creates this very real risk of what experts call stranded capital, which is the nightmare scenario where a company has spent billions on AI chips that they literally cannot plug in and turn on.
So what happens when a resource becomes this critical and this scarce? Well, it stops being just a tech issue and becomes a geopolitical one. Nations are waking up to the fact that controlling their own digital and physical AI infrastructure isn't just a nice to have, it's a matter of national security and power in the 21st century. And this whole idea has a name: sovereign AI. And this isn't just a theory, it is happening right now with enormous amounts of money behind it. You've got Saudi Arabia launching initiatives like Project Transcendence with a potential $100 billion fund to build out its own tech hub. You have India organizing global summits to build up its own domestic AI. And of course, you've got the huge strategic battle playing out between the US and China, where each side is trying to export its own tech stack to gain influence and control over the physical layer of AI around the globe. So with this massive physical arms race happening on a global scale, how can we even wrap our heads around it from an investment point of view? Well, the best analogy comes from history: the gold rush. See, during a gold rush, you can make a super high-risk bet on one specific miner, hoping they find gold. Or you can be the one selling the picks, the shovels, and the blue jeans that every single miner needs, no matter who strikes it rich. In today's AI gold rush, the gold is the AI models themselves. It's anyone's guess which one will win. But the picks and shovels, that's the foundational, physical stuff that all of them have to buy to even be in the game. And these picks and shovels aren't just an idea. They're real, critical industries. We're talking about thermal management, the companies that make the advanced liquid cooling systems, because without them, these AI chips would literally melt. We're talking about high-density networking, the fiber optic nervous system that connects all these AI brains together. You've got the power grid itself, the most basic resource of all. No power, no AI. And then you have the companies that physically build and deploy these futuristic factories of intelligence. So we've gone way beyond just thinking about AI as lines of code. It's a true industrial force, and it's actively reshaping our physical world with data centers, power plants, and miles of cable. And that leaves us with one final, really big question to think about. As AI builds this vast physical empire, who is ultimately going to own the land, both literally and figuratively, that it's all being built on?